Okay, so let's do this ninth question now. So what's the general term of the series? So it's going to be negative 1 power, I think, r minus 1, right? Yeah, it's like it's supposed to be negative 1 power r minus 1. And then it's going to be 10 cr, that makes sense. And then x minus r to the power of 2. Well, x minus r squared, that's going to be like, so it's negative 1 power r minus 1 10 cr. And then this thing is just x squared minus 2rx plus r squared. Yeah, it's almost like that. So what can we do over there? Well, we can indeed find what happens if you put r squared with 10 cr and then calculate that series, and then also this thing minus 2rx stuff. But that's not really what I want, you know. So is there no other way of doing this? I mean, you are getting squares everywhere, aren't you? There should be some other way, you know. So what can that way be? What about we just take a derivative 2 times? Yeah, that should make sense, you know. So let's see. That will be much easier, you know. So you got this thing, you got 1 plus well, I'm not going to use x now, I'm going to use u. So 1 plus u to the power of 10, that is 10c, what is this thing? It's not, no, it's 10. It's 10c0 plus 10c1 into u plus 10c2 into u squared plus 10c3 into u cubed, and so on. And then finally 10c10 u power 10. All right, so now what I'm going to do is that I'm going to multiply this thing. Wait, it's just negative 10 over there, isn't it? Right, and that thing squared. So what about I just put 1 upon u over there? Yeah, so like 1 plus 1 upon u to the power of 10, that's going to be 10c0 plus 10c1 to the power of u power negative 1, and then it's going to be 10c2 u power negative 2, and so on. So like when you put 10c10 u power negative 10 over there. All right, and then what? Well, you also need that x everywhere, right? So maybe we can actually multiply this by u power x. I mean, that looks really creepy, but we are doing that. So we can actually multiply this by u power x, and maybe that will give us something nice. Okay, so let's try doing this. So I'm going to multiply this by u power x, like 1 plus 1 upon u to the power of 10, and then into u power x, that's going to be equal to 10c0 u power x plus 10c1 u power x minus 1. I mean, it's almost like what we need in the series, you know, plus 10c 10c2 u power x minus 1, and so on. So like 10c10 u power x minus 10. Okay, and now we can take the derivative. Nice. So the derivative of this thing, oh god, it looks really bad. Okay, so derivative of 1 plus 1 upon u power 10, that's going to be 1, so 10 into 1 plus 1 upon u to the power of 9. The derivative of 1 upon u, that's just negative 1 upon u squared, and that thing into u power x plus you will have that u power x over there. So like derivative of that thing, man, this is really weird. Okay, so derivative of u power x, that's going to be x into u power x minus 1, and it's just 1 plus 1 upon u to the power of 10. All right, which we can simplify. So it's going to be 10 into 1 plus 1 upon u to the power of 9, actually negative of that thing, right? So it's going to be negative 10 into 1 plus 1 upon u to the power of 9, and then u power x minus 2. Yeah, that should be correct. And then what about this? So like it's going to be x u power x minus 1. Yeah, I mean, like just leave it like that. Yeah, that should be okay. Okay, so we just not leave it like that. We could do that thing as well. So let's just kind of simplify it a little more, because we want to take another derivative, so that will be easy if we simplify this. So it's going to be like negative 10 u plus 1 to the power of 9 and then it's going to be u power x minus, like u power 9 plus 2 is 11, so x minus 11, that should be what we get. And then over here it will be what is this going to be, so like plus x into u power x minus 11 once again, and then u plus 1 to the power of 10. Nice. I mean, this is really frustrating that we have to take the derivative of that thing, but whatever. So this is going to be equal to, so now what? Whether we put, oh, so first of all, take the derivative of the right hand side. So that's going to be x and then 10c0 u power x minus 1 all the way till x minus 10 and then 10c10 u power x minus 11. So now what? Now we can multiply this by u once again. So that's going to make this into 10, right? And then this 1 will get cancelled, and then you'll have 10 over there as well. Okay, and then we can take another derivative. Yeah. Should we first of all simplify this thing? I mean, maybe that will help us. You could take that u to the power of x minus 10 common. No, let's not do that. Or should we? Yeah, it's a tough life decision now. Okay, let's not do that. Because that will make it even more complicated. Okay, so now we'll just take the derivative once again and get done with it. Alright, so let's take another derivative. So that's gonna give me the derivative of this is like negative 10. And then it's going to be 9 into u plus 1 power 8, then u power x minus 10, and over here it should be plus x minus 10 into u plus 1 power 9, okay, and then u power x minus 11, right? This is getting really bad. And then I thought it was going to be easy, but no, it's not easy, it's actually even harder. Plus x into, so now what, u power x minus 1, right? The derivative of that thing, that's going to be x minus 1 u power x minus 2, and then 1 plus, wait, x minus 1, that's weird. Hey, that's actually really weird. But is that, no, it's obviously not correct. It's supposed to be x minus 10 over there, not x minus 1. Yeah, so it's u power, sorry, it's x minus 10 into u power x minus 11. Okay, just do this once again. Where was I? Yeah, this second part. So it was supposed to be x minus 10 into u power x minus 11 into u plus 1 to the power of 10 plus 10 into u plus 1 to the power of 9. Okay, and well, what is this thing? It's going to be u power x minus 10, and that should make sense. Okay, this thing is going to be exactly what we want, except that we have to input the value of u, right? Is this an alternating series? No, it's okay, it is indeed an alternating series. Oh gosh. Okay, so this is going to be equal to, well, let's see. So where is that series? I think this is the series which you wanted. No, that's not it. Where is it? Oh yeah, this thing. No, that's not the thing you want. That's actually simplification. Yeah, here is the series. This is the series which you want. So let's take the derivative of that thing, right? It's x power, so x into 10 choose 2. Yeah, sure, let's take the derivative of that. Things like x squared, it's supposed to be 0 over there, sorry. So x squared 10c0 u power x minus 1 plus x minus 1 squared 10c1 u power x minus 2, and so on. And then finally you should get what is this, like the last one is going to be x minus 10 squared, x minus 10 squared, then 10c10 and u power x minus 11. Okay, so now what? Well, we'll just put the value of u as -1, and that should give us the answer which we want. So putting the value of u as -1, notice that this actually completely cancels. Like this is gone, even this thing is gone, like this complete thing is gone, and then even that thing is gone. Wow, this complete left hand side actually vanishes. So the left hand side is actually 0, right? So 0 is going to be equal to, when you put -1 over there, you should get -x squared, because 10 choose 0 is 1, and -1 power x minus 1. Yeah, so like -1. Okay, just take that thing. So like -x squared, wait, no, something is wrong. So x squared into -1 power x minus 1 plus x minus 1 squared 10c1, -1 power x minus 2, and so on. So now what do we do? Well, we can multiply this thing by, actually divide this thing by -1 power x minus 1, or -1 power x. Yeah, -1 power x will be better. So just cancel that -1 power x everywhere. Okay, so notice that this thing will turn out to be x squared into -1 power -1, which is -x squared. So we can take that on the left hand side, and this becomes x squared is equal to, so this thing is positive because it's an even power, and then the next term will be negative. So the next term will be negative, then it will be positive, then it will be negative, and so on. Yeah, so that's exactly what we wanted. So we actually proved that this this humongous series, this should turn out to be x squared, and this was fun. Okay, I will see you in the next video.